Very good afternoon to all of you present in the session. We are going to continue our discussion of Dijkstra's algorithm with, first of all, with undirected graph and then with a directed graph. Okay.
Ma'am, can you start this algorithm from again, from settings?
Yes, I'll do that. See, the goal of this Dijkstra's algorithm is that it wants to find a shortest path from a source to all the other vertices. It doesn't say that it want to find shortest path from, let's say, fixed source and all other vertices. Source can be any, and the remaining vertices are the other vertices for which the shortest path is to be found out. Okay, and that's why it is also known as single source shortest path. Like for example, if I start from A, okay, then from A to B, what is the shortest path? A to C, what is the shortest path? A to E, what is the shortest path? Okay, so my source remains the single starting source. Similarly, if I want to find from B, okay, so B to A, B to E, B to D. Okay, so that's why it is known as single source shortest path algorithm, where you are searching the shortest path from a single source or say a fixed source to all the other given vertices. Okay, now there is a working principle of this Dijkstra's algorithm. Okay, let me remove this all first. I'll explain it to you again. Okay, the working formula of the Dijkstra's algorithm is, if you have to check, okay, that distance of your source, this u represents source, okay, this v represents the destination. Okay, so if distance of source plus the edge weight between source and destination, okay, is less than the distance of my destination, okay, then go and update the destination value of the distance. Okay, so what we are finding here, we are finding the distance. Okay, we are finding the distance, and what we are taking into consideration, the distance of your source plus we are considering the edge weight, or say the connection weight between your source and destination. So arbitrarily, if I choose 0 as my source, okay, then what is the initial step, first step for this? Currently you just know that 0 to 0 distance is what? 0. Okay, so the value d of u for this is 0. Now we don't know what is the distance from 0 to 1, 0 to 4, 0 to 8, 0 to 2 right now. We are yet to determine that. Okay, so what we are going to do, we are going to assign initial values as infinity to each of your vertex. Okay, so each of the vertex is assigned infinity. Okay, infinite here, infinite here. Each of the other vertex you are going to give the same thing. Fine, done. Now you start the process of exploring your vertex. Okay, like from 0, if what is the shortest path to 1, from 0 what is shortest path to 4. So what we are doing, we are exploring the vertexes here. Okay, so for 0, so distance is 0 for my source 0. Okay, what is the connection? Let's say the adjacent, you have to identify the adjacent elements. Okay, so here what you are going to write, u value. Okay, selecting initially your u value as 0. Okay, what are the corresponding v values for this source 0? V values is 1 and 4. Okay, 1 and 4. So start with 1. Go and find the distance at 1, because see, 1 distance is infinity, 4 infinity. Infinity means we don't know yet. It can be any number in my infinity. Okay, so 0 plus, now C of uv is what? The edge weight between 0 and 1. Okay, so edge weight is what? 4. Okay, so 4. is less than what is currently the distance of your 1, that is v, infinity. So obviously 4 is less than infinity. 0 plus 4 is 4. 4 less than infinity. Yes. So what you're going to do, you're going to update the value of distance from 0 to 1. Now 0 to 1 distance is what? 4. Now it is not infinity. Okay. I'm talking distance. Okay. Now go and check for number 4, vertex number 4 here. What is the distance? Again infinity. So I have to determine the distance from 0 to 4. Okay. So distance of source 0. It is 0. Okay. Plus edge weight between 0 to 4 vertex, that is 8. So 0 plus 8 is less than distance of vertex 4. Okay. So that is infinity. So obviously 8 is less than infinity, so you are going to update the distance 0 to 4 as 8. Okay, done. Now, how are you going to choose your next source, next single source? Because see, if there was one more, one more vertex this side from 0, then you would have explored that also. But now all the possible values, or say the nearby edges of 0 are explored. Okay, so now we have to choose another source. How we are going to choose another source? From 0, whichever vertex is having the shortest distance, whichever vertex is having, or say in general manner, from your source, whichever vertex is having the shortest distance, don't consider this edge. Okay, don't consider this edge weight. I am talking shortest distance. That vertex you are going to choose as your next source. Okay, so this was your step 1. Choosing your arbitrary vertex like 0 was your step 1. Now step 2 is what? Select the shortest distance vertex out of all. Okay, so the shortest distance is what? 4, because 4, 8 and rest of them are infinity. Okay, so 4. So you now value is what? Your vertex number 1. Okay, because that is the distance having value 4. So vertex 1. Now look for all the adjacent vertex of this one. Adjacent vertex is what? 4 and 2. Okay, so you have to find the distance between 1, 4 and 1, 2. Okay, so again you will go and do the same calculations. Okay, distance of 1, now it is what? 4. D of u. Okay, so d of 1, it is what? 4. So what you will write here, let me just erase this. Okay, see, now it is distance 1. Distance 1 we have now, and determined finite value we have is 4. So 4 plus what we are searching for. First of all, 1 to 4. Okay, so 1 to 4, what is the edge weight? 11. Okay, so 4 plus 11, that gives me 15. 15 less than distance of v. What is v? V is this vertex 4, and the distance we have determined it, so that is 8. So 15 less than 8, so we don't need to do any changes. 8 is already the shortest distance. Okay, so that is done. Fine. Now go for 1 to 2. Again, d of u is what? 4. Okay, and plus edge weight between 1 and 2, so that is 8. Okay, so 4 plus 8 is 12. 12 less than distance at 2. Distance at 2 is right now infinity. So obviously 12 is less than infinity. So what you are going to do? You are going to update the distance here, 12. So from 0 we went to 1. Okay, so both 0 and 1 explode. Okay, now again repeat the same process. Look for the distance which is the shortest one. Okay, which is the shortest distance out of all? In a given graph, which is the shortest distance out of all? Which vertex is having the shortest distance and which is not explored? Correct, Shri. 4 is the vertex. 4. Okay, which is having the shortest distance among all the vertices which are yet to be explored. So now you are going to go at 4. Okay, so your u now, your u is what? 4. Okay, and what are the v values nearest vertexes to 4? Which are those? Can anyone tell me? 8, 5, yes, and 0 and 1, yes, correct. But are you going to explore 0 and 1? You are not going to explore 0 and 1. Why? Because they are already explored. Okay, the only ones which are not explored right now is 8 and 5. Okay, so you are going to consider or say find the distance from 4 to 8 and 5, repeating this same process. Okay, so if I erase this, okay, now tell me what is d of u in this case, in our case for 4 to 8, d of u?
4.
8. D of u value I'm asking. Okay, Tushar? So 8. Distance. D of u is what? Distance of 4. So that is 8. Okay. What is the edge weight between 1 and 8? It is 7. Okay. And what is the distance at 8 currently? It is infinity. Okay. So 15 is the value which I get. 15 is less than infinity. So you are going to update this infinity sign now to a finite value of distance as 15. Okay. Now, similarly for 5. Again, distance at 4 is plus edge weight between 4 and 5 is 1. And distance at 5 currently is infinity again. So 8 plus 1 is 9. So you will update this infinite value to a finite value of distance as 9. Okay. So that means 4 explored. Now again go and choose your u. What will be your u now? Value for u? Correct. 5. The reason is vertex phi is having the shortest distance among all the existing non-visited vertex. Okay. So your u value is vertex phi. What is the v value for vertex phi? List out. List it out. V value from vertex phi. 486. Correct. I guess only Shri is getting the concept. What about rest of the students? It is nice to see that Shri is answering it. I don't think other students are getting it or not getting it. What? What is the problem? Okay. For VU value 5, V value you have 4, 8 and 6. Okay. From 5 you have see 3 incident edges 4, 8 and 6. Okay, but 4 you are not going to explore. Why? Because it is already explored. Now we are going for 8 and 6 which are unexplored. Okay, so again you are going to do what? 9 plus 6. So 9 plus 6 is 15. 15 less than 15. Do I need to do that? Do I need to do that? No. Right? So this I am not going to update. Again, 9 plus 2. So that is 11. So 11 less than infinity? Yes. So cross this infinity and write 11. Okay, fine. So now 5 explored. Okay, so 0 to 1, 1 to 4, 4 to 5. Okay, now which is the lowest distance again? The lowest distance is of 6, vertex 6. So your u value now gets updated to 6. What is the v value for it? Anyone? V value for your 6?
11.
Correct. No, 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 no. V value means the adjacent distance from your vertex 6. I'm not
Okay,
asking distance. Which are the adjacent vertexes? Or say the
2375.
incident edges. Exactly. See, you can directly see here 5, 2, 3, and 7. Okay. So out of there, again, 5 is not going to get explored. Which one we will explore? 2, 3, and 7. Okay. Now go and check again. Distance of 6. So that is 11. 11 plus 4. 11 plus 4 is what? 15. 15 less than 12 because at 2 we have a finite value. So 15 less than 12, no. So we don't need to update this 12. Okay, it is already the shortest distance possible. Fine. Now check for 3. Okay, 11 plus 14. So that gives me 25. 25 obviously less than infinity. So you are going to update your infinity from infinite value to 25. Okay. Now 6 to 7 again. 11 plus 10. So that gives me 21. 21 is less than infinity. So cross this infinity out and write 21, update the distance. Okay, so 6 explore. Fine. Now see, now this is again you are going to check which one is the shortest distance out of all. The shortest, next shortest distance is which? 12.
Vertex 7.
No, it is 21. It is 21. Here it is 20. You have to look for the distance. Okay? You have to look for the distance that out of the remaining unexplored vertices, which one is having the shortest distance? So again, I'm saying you don't consider edge. You don't consider edge. Consider the distances. Distances is what we are writing or we are updating here on the top of the vertex. Okay. So what are the list of distances? 12, 15, 25, and 21. So 12 is the shortest one. Okay. So U value now is what? Vertex 2. Now from vertex 2, you find the incident edges which are not explored. So that is 8 and 3. 1 and 2, 1 and 6 are explored. So you are not going to consider that. Okay, so 8 and 3. And why we are considering 8 and 3? Because they are not explored yet. Okay, so again you will find the distance. That do you need to update this distance 15 and 25? Okay, do you get any shorter distance? Let's see. So if we consider 2 and 8, 2 as my source, 8 as my destination. Okay, so 12 plus 2, so that is 14. Okay, 14 is less than 15, correct? So you are going to update this 15 and you are going to write 14 because we got a shortest value which is less than 15. So you updated the distance. Okay, now go and check for 3. 12 plus 7, so that is 19. Okay, 19 is obviously less than 25. So you are going to update this distance from 25 to 19. Okay, with this we explored your vertex 2. Now again go and check next value of u. Okay, next value of u will be the shortest distance vertex. Which is the shortest distance? Tell me.
14 and vertex 8.
Correct. So vertex 8. Okay. Again, you will find the V values. What is the V value for all those vertices? See, 4
All are
explored, so you're not
common.
going to do that. Okay. 5 explored, so again you are not going to consider that. Even 2 is explored, so you are not going to consider that. So in this case, you got the shortest path. You already have the shortest distance. Okay. So you are not going to do anything. This 14 is the final distance for this vertex 8. Okay. Now next, your U value. So 8 is explored. Okay. Now next, your U value will be the shortest distance out of the unexplored vertices, that is 3 and 7. Obviously it is 3. Okay. So next your U value is what? 3. What is the V value for this? It is 2, but it is explored, so you're not going to consider that. Then it is 6, again explored, so not considering that too. And then there is 7. Okay, so again we are going to do what? 19 plus 9. So that gives me 28. Okay, 28 is less than 21? No. So no change. Okay, this remains 21 as it is. Okay, so 3 also got explored. And for 7, there is nothing to explore because 3 is also explored, 6 is also explored. So for u equal to 7, okay, nothing to be done. 21 is the final destination. So you found out that from 0 to 1, if you want to reach, then what is the distance? 4. Okay. From 0 to 4, if you want to reach, then what is the optimum distance? 8. From 0 to 5, from 0 to 5, if you want to reach, then what is the shortest distance? 9. You can reach, like, there are multiple paths to reach to 5. Okay. Suppose from 0, 0 is my, source vertex. Then there are multiple paths. I can go from 0, 1, 4, 5. I can go 0, 1, 2, 8, and 5. Okay. I can go 0, 1, 4, 8, and 5. But out of this all possible path, which is the shortest distance path, it is 9. The shortest distance to reach to vertex 5 from 0 is 9. That is what these distances indicate. Got it? Any doubt here, anyone? Yes or no? Okay. This was for the directed graph. Okay. Sorry. This was for the undirected graph. Now, if we talk about directed graph, okay, then, okay, just wait. If we talk about this is what your directed graph. Okay, there are arrows. Then again, you are going to do the same thing. Formula you are going to apply the same. Okay, if I just go and take this formula for you. Okay, the formula is going to be the same. There is no change. You are going to calculate the distance. Okay, and see if the distance is less than infinity, then you are going to update. But how you are going to do this here? You are going to do this here with the help of a table. Okay, so in that table, what you are going to write? You are going to first of all fill out the row. Okay, so the heading of that row is what? The name of your vertices, all the possible vertices. So A, okay, B, C, D, and E. Okay, which how the number of vertices present. Okay, that consists of your rows. Now your column shall consist of the selected source. Suppose I am selecting A as the source, then I will write A here in the column first. Okay, if I am selecting B as my single source, okay, then I'll write B here. Right now let's consider A as my single source, and from A I want to find the shortest path to E, D, B and C. Okay, so I will first of all write A. Okay, now following the same rules, okay, A to A distance is 0. Okay, and guys, I don't know the rest of the distances, so what I'm going to write, I'm going to write infinity to the each of the vertex. A to B is infinity, A to C is infinity, A to D is infinity, and A to E is infinity. Okay, now we are going to start writing, like updating this distance values. Now again, see, A to A is what? D of U 0 plus, if we talk about B, A to B, okay, edge weight is what? 10. Okay, so 0 plus 10 less than, again, infinity. Okay, so that is what? 10. 10 is obviously less than infinity. So what you are going to write in the next row? You are going to update this infinity value to 10. You are not writing this 0 again here, okay, because we don't need that value. We are searching from A, so again you don't need to write here 0 in this second row. Okay, we updated the value for B, distance of B. Similarly, do it for C. But you have to look, can you reach from A to C? You cannot write A to E. Okay, why? Because you cannot reach, there is an edge between C and D, but A is the destination and E is the source there. Okay, because this is a directed graph. All right, now from A being the source, what is the next destination? C. Okay, so again go and check. 0 plus the edge weight, that is 5. Okay, so 0 plus 5 less than infinity. Yes. Okay, so you are going to update here the value 5. Now as you cannot, as there is no direct arrow from A to D and from A to E, okay, values you are going to write here as infinity and infinity. Okay, so you are done with your vertex A. Now go and see that which value is the shortest one out of these 4. Which value is the shortest one out of these 4? The value, or say the distance of which value? Yes, correct. 5. Okay. So now as the distance at vertex C is the shortest, you are going to select your source, next your source as C. Okay, now look for C. From C, you can go to B, you can go to D, and you can go to E. Okay, A we are not going to consider. Fine. So now go and look for B to C first. Okay, at C the distance is what? 5. Okay, the distance that we got is 5, and at D right now currently the distance is what? 10. Okay, rest of them are at infinity and infinity. Okay, so now C to B, so 5 plus 3, so that is 8. 8 is definitely less than 10. So what you are going to do, you are going to update the distance value at B. So from 10 it is now 8. Okay, now C to C is obviously, not going to get considered. We are not considering. Now C to D. Okay, C to D is what? 5 plus 9. 5 plus 9 is 13. Oh, sorry, 14. Okay, so 14 is obviously less than infinity, so update that. So in the table, instead of infinity, you are going to write 14. Now look for C to E. 5 plus 7. 7 is less than infinity. Yes. So go and write 7. Okay, so these are the distances. Okay, so this is 7 here, this is 14 here from vertex C. Okay, now again repeat the same process. Look for which distance vertex is the smallest, for which vertex the distance is
E.
smallest. E. Okay, so now you are going to consider E as your source. Okay, so next is what? E. Fine. Now for E, it can reach to A, it can reach to D. Okay, so for A, from E to A, okay, so that is 7 plus 2. So 7, Yes, okay. Yeah, it is 7 plus 2. Okay, so that is 9. But we are not going to explore A. Why? Because that is our source. Okay, in our Dijkstra's algorithm, A is what we have considered as source. So even if this 7, we do have an edge from E to A. Okay, we are not going to update the distance, and it is not possible also. If we look at the mathematical way, A is having distance 0. 0 is already less than 9. Okay, so you're not going to consider that edge. The remaining one is what? The D. Okay, so for that, what you are going to consider again here for D? So 7 plus 6. Okay, what is the value? 7 plus 6? 13. Okay, so 13 is less than 14? Yes. So you are going to consider here 13. Okay, now this B value you are going to write here as it is. Okay, so far we were not writing these zero values. Why? Because the possibility of anything less than 0 is none. Okay, the distance can be a positive value. Okay, so that's why we are not writing. But here in case of our B, we will write 8 here along with 13. Why? Because there can be a possibility that there is a number less than 8 for this given distance B. Okay, so that's why we are going to write 8 here. Now go and consider which is the shortest path. I mean the vertex having the shortest path, B. Okay, because it is having value 8. So here you are going to write B. Okay, now go and check from B. From B you have only one edge that is going to D. So go and check that, do you get any shortest path less than 13? Okay, previously it was 14, then it got shortened, so it was 13. Do you get any more shortest path? Yes. Why? Because 8 plus 1 is 9, and 9 is less than 13, so you are going to update this value. Okay, fine. So this 13 you are going to remove, and it is 9 now. Now for this D, there is no vertex which is unexplored. Okay, so now in this case, how you can figure out that what is the shortest distance? If suppose from A you want to reach B, then what is the shortest distance? Shortest distance is 8. Okay, shortest distance from A to B is what? 8. Because see, you can go from A to C, okay, and C to B, or you can directly go to A to B, but A to B is 10, and if you look edgewise, okay, then 5 plus 3 is 8, so that is the shortest distance. Okay, so again, for A to C, if you want to reach A to C, which is the shortest distance? 5. From A to D, which is the shortest distance? 9. Okay, A to D, if you want to reach, you can reach A to D from like A to C, then C to B, and then B to D, like this. But there is one more path, A to B and B to D, like that. Okay, or you can even reach A to C, C to E, and E to D, like that also. But out of all these possible paths, which is the one having the shortest distance? It is 9. Okay, so A to D, the shortest possible path is the distance 9. Similarly for E, to reach till E, which is the shortest distance from A, it is 7. Okay, so this is what your Dijkstra's algorithm works in the directed and undirected graph. Clear, everyone? Okay, fine. So now next we are going to discuss your Warshall's algorithm. Okay, this is the third kind of algorithm in the shortest path. But before going to the Warshall algorithm, we understand a small topic of path matrix. Okay, now see, this path matrix is actually a matrix that represents the optimum path. Okay, the path matrix represents the optimum path that do you, or say in other words, it will say that can you reach from a given vertex to another vertex? Yes or no, 0 or 1. Okay, if your path matrix is having the shortest distance, okay, for all the vertexes from a given source, okay, then your path matrix will be completely filled with values 1. Okay, it will be 1 1 1 1 given in your n cross n matrix. But how you are generating that? Okay, see, your path matrix is used to show whether there exists a simple path from your node v of I to v of j or not, yes or no, okay, 0 or 1. If there is a simplest path means the shortest path, okay, then if it is exists, then the path matrix corresponding to that vertex is, suppose A to B, there is a vertex, sorry, there is a simple path or shortest path. Then in the path matrix, value of A cross B will be 1. Okay, similarly for A cross C will be 1. B cross A will be 1. Okay, so that is what the path matrix is used for. It is used to show whether there exists a simple path from your node V of 1 to V of I to V of j. Okay, now in the case of path matrix, we are going to consider your adjacency matrix. If you do remember your adjacency matrix, what is adjacency matrix? Anybody? What is adjacency matrix? Or how can you write your adjacency matrix? I told you that we are going to use it in
I
Warshall.
plus 1, j plus 1.
I plus,
1, j plus 1. If we are taking rows and column in the matrix.
okay. So if in simplest words, Tushar, absolutely right. In simplest words, do you remember I told you that if there is loop, then the main diagonal will be consisting of value 1. If it is not, then main diagonal values are zeros. Okay, and if there is a connection, it is directed or undirected. If there is a connection, then you are going to fill your adjacency matrix accordingly. Just a revision, let me tell you. Remember this diagram? See, there are no loops and it is a directed graph. So main diagonal 0. A to B I have connection, so I have written 1. Okay. I am not concerned with the distance. Do I have a edge connection? Yes, then 1. If I don't have edge connection, then 0. Now can you guys recall the adjacency matrix? Because this is important for Warshall. Yes? Okay. Others? This Bharti? Okay. Now this is adjacency matrix. Now from this adjacency matrix, just give me a minute, please. Okay, fine. So see, in your Warshall, we are going to use this concept of adjacency matrix. Okay. Now this Okay. Now, if we represent our adjacency matrix as A of 1, the name of our adjacency matrix, if we are keeping it as A of 1, then we can conclude that there is an entry 1, means there is a simplest path, okay, from ith row to jth column. Okay, that is what we are, representing. What exactly we are representing, that is what I'm trying to explain it to you here. Okay, that if there is an adjacency matrix named A of 1, okay, and there is an entry 1 in that adjacency matrix at ith row and jth column. Okay, that means there is a simple path existing of length 1 from v of I to v of j. Okay, now similarly, it can be said for your vertexes 2, 3 till your vertex n. Okay, what is A of 1? A of 1 is your vertex. Okay, you can do the same thing for your A of 2, A of 3, and A of n. Okay, and if you want to find the path matrix or say the shortest distance using the matrix, okay, then ideally what you do, okay, in order to find a path
Insertion.
matrix, what you do is first you find out A of 2. A of 2, you are doing your matrix multiplication. Okay, so A of 1 cross A of 1. Okay, so you will get some resultant array which is your A of 2. Okay, now you will find A of 3. A of 3 is again A of 2 cross A of 2. Okay, so see this resultant you got. Okay, A of 2 you are getting here. This is your A of 2, the final answer. Okay, now if you find A of 3, okay, then this is what A of 2 cross A of 2. So you get a resultant array, okay, which is the value for A of 3. Okay, and if you see, the values are changing from zeros and ones. Initially it was zeros and ones only, A of 1. Okay, at A of 2 you get an updated distance, that is 2. Okay, so distance, these are what your distance values. Okay, now you are checking for A of 4. So again A of 3 cross A of 3, so you get some value here. Okay, and after that, suppose there are 4 vertexes. Okay, so you find out 4 times the various the values, so A of 1, A of 2, A of 3, and A of 4. Okay, and based on these matrices that you get, you are going to do the summation and define a matrix B of R. Okay, so what is matrix B of R? Summation of A of 1, A of 2, and A of 3. And like A of R. And R value is what? The number of vertices that you have. Okay, till here, everybody with me? Okay. Now see, what is the main goal to define your matrix B? Why we are defining this matrix B? Okay, so that we can obtain your path matrix P. Now, what is this path matrix P? If for any given value in your matrix B, if that value is a non-zero value, okay, if your resultant summation array, okay, suppose this one is your B matrix, okay, for example, it is not actually, but for example, this is the matrix that you get for the summation, after the summation. Okay, then for every non-zero value of matrix B, path matrix P will have value 1. Okay, so at value 0, 0, path matrix will be 1. Okay, this is your path matrix. Okay, at value 0, 1, again I have a non-zero value, so path matrix value 1. At 0, 2, okay, non-zero value, so path matrix again 1. Suppose here it was 0, suppose. Okay, then path matrix at 0, 4 will be 0. Okay, like that you are going to fill for each and every ith row and jth column for your path matrix. Okay, so that's what this sentence says. The main goal to define your matrix B is to determine your path matrix. And how your path matrix is getting structured or calculated? By setting P of ij value as 1 for every value of B of ij as non-zero. If B of ij value is 0, then you are setting P of ij value as 0. Okay, something like this. See, here you are getting this B value. Okay, there is no 0 here. So your path matrix will contain all the ones. Okay, got it? Yes or no?
Ma'am, can you recall it once again?
Okay. How you are constructing this path matrix P? How you are getting all these ones? These ones are constructed based on the values of this B, matrix B. If in this matrix B, you have non-zero values, okay, you have a non-zero value here, you have non-zero value here, you have non-zero value here. So corresponding to those positions in path matrix P, you are going to write 1 if the value is non-zero. If the value is 0, then at corresponding position in matrix P, you are going to write 0. Now you got, Tushar?
Huh.
Okay. So see, this was the path matrix, okay, but this is very, lengthy, very tedious. Why? Because it was, even if it was, my 4 vertices, okay, my R value is what? 4 vertex. Okay, how many multiplications I did? Matrix multiplication, that too. Okay, so if my vertices are 6 or 7, then I have to go to so much of lengthy process. Okay, even after doing the multiplication, which is the lengthy process, okay, I have to do the summation also. Okay, so that becomes a tedious job, or say the tedious method to find, or say to determine whether there is a shortest distance existing or not. Okay, so to ease this out, Warshall came up with an algorithm. Okay, and in this algorithm, what we are looking at is we are looking to some, possible shortest path from a given vertex via a middle element. Okay, in Dijkstra's algorithm, what we were doing, you were, finding out the shortest path from one vertex to all the other vertex. Okay, one by one after the another. Here, what you are going to do, you are going to find all the shortest path from a given vertex, okay, via a target vertex, okay, via one vertex. So see, we will solve one example first, okay, and then we shall, derive on the formula which is it is working on, the generalization. Okay. So see, Warshall is, giving you an efficient algorithm to calculate the path matrix. Okay. Here, now the matrices are addressed as P0, P1, P2 like that. Okay. And what that algorithm says, that if there is a path from your source to the destination, okay, via some node, your node should not be out of V1, V2 और VK. ओके, अगर आपके पास 1 से लेके 6 तक नोड्स है जो कि कनेक्टेड है, तो आप ये 7वें वर्टेक्स को नहीं इंट्रोड्यूस कर पाओगे. ठीक है, द पाथ शुड नॉट यूज एनी अदर नोड्स except from 1 to 6. Okay, and if there is a path from, let's say, 1 to 4 via some, vertex, then you are going to write the path matrix value as 1. और अगर पाथ नहीं है, शॉर्टेस्ट पाथ नहीं है, तो आप 0 लिखोगे. ठीक है, ये उसका एक थियोरिटिकल प्रिंसिपल है वॉरशॉल का. अभी देखो, we are going to, solve this example of Warshall. All right, and we are going to see how the algorithm is working, like how it is coming up with the path matrix. Okay, abhi, see, now the rest of the slides, okay, they consisted of mathematical steps. So basically I have added the pictures of my notes. Okay, जो भी notes है मेरी और जहाँ पे भी मैंने ये example पूरा solve किया है उसके pictures है. Okay, so we are going to go through those. Okay, because वहाँ पे सारे mathematical calculations है and they are not possible or say quite efficient in showing it in the slides. Okay, let's start with the example. आपको पता चलेगा क्या हो रहा है. ठीक है, algorithm में क्योंकि maths है, maths सबको पता चलता है. ठीक है, now चलो ये आपका ग्राफ हो गया. ठीक है, this is the given graph. Fine. And very first step which you are going to do is you are going to find the adjacency matrix. Okay, which is your initial matrix. So you are going to do your A of 0. ठीक है, आपके वर्टेक्स कितने हैं? 4. So 4 cross 4 की matrix. Okay, so and because it is a directed and weighted graph, so instead of ones and zeros you are going to mention the weights. Okay, so देखो 1 of 1, so वो तो 0 में कहीं पे लूप नहीं है, पूरे ग्राफ में कहीं पे लूप नहीं है. ठीक है, तो आपका जो मेन डायगोनल है वो 0 हो गया. ठीक है, now 1 to 2, do you have a path? Yes, I do have a path, but in this case what we need to do, we have you know 2 paths. Like it is 1 to 2 I have one path, and then from again 2 to 1 I have another path. But here we are talking about 1 to 2, so you are going to record 30. Okay, then 1 to 3, do you have any path edge? I do have an edge, but it is not from 1 to 3, it is from 3 to 1. So at 1 to 3 what you are going to write? Infinity. You don't know the distance. Okay, 1 to 4, do you have any path? Yes, you have. And what is the weight? 12. Okay, so 12 is written here. Similarly, you are going to fill for 2. 2 to 1 you have, so 18 is filled up. 2 to 3 you have, so 12 is filled up. Okay, 2 to 4. 2 to 4, do you have? No. So infinity. So like this, you are going to fill up your A of 0. A of 0 is what? Your adjacency matrix. That is your initial matrix. Everybody with me till here? Okay. Now we will start the working of our algorithm. Now, as I told you, we are going to find the shortest path via a vertex. Okay, via one vertex. Okay, let's say we want to find a path from 2 to 4. Okay, via 1. Or let's say I want to find a path from 3 to 2 via vertex 1. Okay, so is there any possibility that despite of having these distance values in my adjacency matrix, there is some value which is less than these distance via 1? So that is what we are going to calculate. Okay, so the next step is find out any shorter path between the two vertices going via vertex 1. Okay, so now keeping A of 0 as your reference, okay, you are going to construct A of 1. Okay, what is this one? This one is the vertex via which we are finding the distance. Okay, now as we are finding the distance, considering the vertex 1 as the in between vertex. Okay, the row and the column values of this one will remain as it is. Okay, see here the values was 0, 18, 15, 17, 0, 13, infinity and 12. So that will remain as it is. And all the remaining blank values, this is the blank value here, this is the blank value here, this is the blank value here, and these two are the blank values. Okay, so for this you are going to find whether there is a shorter path than the existing one. What is the existing short paths? They are infinity, 11, infinities and infinities and infinities. Okay, so that is what you are going to have a look here. Okay, so what is the first thing that you are going to do? You found out, I mean, like you wrote down these rows and column values of one same as it is. Next, you're going to check, are there any self loop? No. So the main diagonal you're going to fill out as 0, 0, 0. Okay. Now you are going to check. This position will be blank. Okay. We don't know what is 2 of 3 distance as of now currently. Just let me write a of 0 here so that it will be easier for you to understand. Okay. 0, 13, infinity 12. Okay, and 18, 15, 17. This is A0, okay, so that I don't have to flip between the slides. 18, 15, and 17. Okay. 0, infinity, infinity. 12, 0, infinity. And it is infinity 11, 0. Okay. Now this is your A0. A0 as reference. Okay, you are going to write this column as it is for 1. Now we are saying that we want to find shorter path via vertex 1. So shorter path from 2 to 3 via 1. Okay, so what you are going to do is you are going to do the summation of 2 to 1, okay, and 1 to 3, because see you are inserting 1 in between 2 and 3. Okay, and you are going to compare with the existing distance of 2 and 3. The existing distance between 2 and 3 is what? 12. Where did you get that 12? From your A0. Now if you insert, if you place vertex 1 in between, okay, then you have to do the summation of which values? A of 0 to 1, A0 to 1, A0 to 1 is what? 18 plus A0 1 3, because how you want to go? 2 to 1, 1 to 3. Okay, like that you want to go. So 1 is placed in between 2 and 3. Okay, so A0, 1, 2, 3. What is 1, 2, 3? It is infinity. So 18 plus infinities. So that is infinity again. And 12 is less than infinity. So already a better path. Okay, so you are not going to change anything. In this matrix A of 1, you are going to write 12. Are you guys getting? Yes or no? Students, see, there is a mathematics here. Okay, so that's why this is the theory which you need to understand, that how exactly the metrics are getting built up. Instead of doing matrix summation and then multiplication, matrix multiplication and then summation, we are updating our final matrix. Okay, we are generating our B matrix here. Okay, so that means from A of 0 we are now generating A of 1. From A of 1 you will generate A of 2. From A of 2 you will generate A of 3. Okay, so like that we are doing. Okay, so I hope why this 12 is there is clear to everyone. Is there any doubt? Because see, everything is interconnected. If in further slides you are not getting, then I have to go back to this initial stage and then I have to again go and explain and reach there. So it will be a very, lengthy process. So tell me if there is any problem till here. Okay, I guess no doubts. Everybody is pretty quiet. So I think there is no doubt from your end. Okay. So that is for this one missing value. Okay. For this one missing value from 2 to 3. Now we are going to check for 2 to 4 via vertex 1. Okay. So the same thing we are going to do. A of 0, 2, 4. Okay. A of 0 now will be 2, 4. Okay. And here A of 2, 1 and A0 of 1 and 4. Okay. What is A0 of 2, 1? Answer me. 18. Written already. A of 1, 4. What is it?
12.
A0, 1, 4.
12.
A0, 1, 4. 12. Okay. Now, and what is A0, 2, 4? A0, 2, 4. What is it?
Infinite loop.
Correct. Infinity. So, does infinity less than 30? This is summation. This summation gives you value what? 30. Infinity is not less than 30. Okay. So, this value from 0 shall be updated here in A1. The best possible distance from 2 to 4 via 1 is 30. Okay. Or say the best possible path from 2 to 4. If I want to reach 4 from 2, then it is via 1 having a finite value as 30 instead of infinity. Okay, so we generated one, we generated matrix here, matrix B. Okay, which B is containing what? The shortest possible distances. Okay, now you guys are getting थोड़ा थोड़ा तो पता चल ही रहा होगा कि क्या हो रहा है. पूरा नहीं पता चल रहा तो ठीक है, लेकिन थोड़ा बहुत तो पता चल रहा है कि क्या हो रहा है. ठीक है. Yes or no? Okay. Next, missing value जो है वो आपकी है 3 और 2. You are going to apply the same procedure. A of 32, A032. Okay. Is it less than A0 of 3, 1 and 1, 2? Okay. अगर आपको कोई छोटी वैल्यू मिल रही है, okay, then the existing value. If suppose like this, infinity से छोटी वैल्यू हमें मिली 30. ठीक है. So smaller than infinity, so update the path. Now what we are deducing based on this, what we are deducing that there is no direct path between 2 to 4. हमारे एग्जाम्पल में अगर आप देखने जाओ तो देखो डायरेक्ट पाथ 2 से 4 तो है ही नहीं कोई कि डायरेक्टली 2 से निकल के यहाँ पे 4 तक पहुंच गए. ठीक है. बट देर इज अ पाथ from 2 to 1 and 1 to 4, which is the shortest among all. Okay, there is a path from 2 to 1 and 1 to 4, which is the shortest amongst the all, and that's why a B हमने यहाँ पे 30 लिखा है. अगर आगे जाके कहीं पे भी ये वैल्यूज अगर चेंज होती है, मतलब एज वैल्यूज चेंज होती है, तो आपकी ये डिस्टेंस वैल्यूज भी चेंज हो जाएगी. ठीक है. क्यों? क्योंकि इनिशियली जो हमारा A0 है, ये जो A0 है हमने किस से बनाया था? एज वैल्यूज से. तो ऑब्वियस है कि ये एज वैल्यूज चेंज होगी तो आपका यहाँ पे डिस्टेंस भी अफेक्ट होगा. ठीक है. You guys are getting that what we are deducing from this and what is A1 and all. Okay, I hope it is clear to everyone. The same procedure you are going to do for these empty vacant spaces. 3 to 2 via 1, 3 to 4 via 1, 4 to 2 via 1 and 4 to 3 via 1. अगर ये सब कुछ कैलकुलेट करते हो तो आंसर्स वुड लुक समथिंग लाइक दिस. ये आपका A1 है. देखो 3 to 2 A0 में क्या था? इन्फिनिटी. अभी चेक करो कि इन्फिनिटी से छोटे वैल्यू, छोटे डिस्टेंस मिल रहा है क्या? वाया 1 मिल गया. तो व्हाट यू आर गोइंग टू डू? इंस्टेड ऑफ इन्फिनिटी यू आर गोइंग टू राइट 28. ओके. सिमिलरली फॉर 3 to 4, 3 to 4 A0 में वैल्यू है 11. 11 से डिस्टेंस में मैं जा सकती हूँ 1 से, तो 15 plus 2 so that is 27. नहीं, 11 अभी भी आपका शॉर्टेस्ट डिस्टेंस ही है. ठीक है. यू आर नॉट गोइंग टू अपडेट दैट 11, that means same as it is. Okay, for 4 to 2, 4 to 2 क्या है? इन्फिनिटी. ठीक है. इन्फिनिटी से छोटी वैल्यू मुझे मिल रही है 4 से 2 via 1. Yes, that is 30. Okay, so 30 is updated here instead of infinity. Fine. और लास्ट है A2 4 3. 4 3 मेरा इनिशियली A0 में इन्फिनिटी है. ठीक है. अभी वाया वर्टेक्स 1 मुझे इसकी छोटी डिस्टेंस वैल्यू मिल रही है? नहीं, क्योंकि वो इन्फिनिटी है. ठीक है. तो वहां पे फिर से इन्फिनिटी लिख दिया. तो ये आपका क्या हुआ? A of 1 हुआ. दैट वाया वर्टेक्स 1 which are the shortest path from a source to the destination. Okay, समझ आया यहाँ तक? ये एक साइकिल पूरी हुई. ओके, ये एक साइकिल पूरी हुई. ऐसे आपको सब वर्टेक्स के लिए देखना है. फॉर वर्टेक्स 2, फॉर वर्टेक्स 3 एंड फॉर वर्टेक्स 4. समझ आया? ये प्रोसीजर समझ आई? Students, I need you guys to at least speak up yes or no. Okay. Now for vertex 2, we are going to search the shortest path, possible shortest path via vertex 2. ठीक है. क्योंकि हो सकता है ना कि अभी सपोज हम लोग 3 to 4, यहाँ पे हमारा ये जो वैल्यू है, सपोज ये यही ले लो. ठीक है. 4 to 2, 4 to 2 है जो, ठीक है, वो है 30. ऑलराइट. अभी फिलहाल शॉर्टेस्ट डिस्टेंस ये है. ठीक है. लेकिन वो कब था? वाया 1, क्योंकि वो A of 1 की मैट्रिक्स में है ना. 4 से 2 अगर मुझे जाना है वाया वर्टेक्स 1 तो मेरा डिस्टेंस है 30. बट अगर मुझे 4 to 2 जाना है वाया वर्टेक्स 3 तो वो कितना है? ओके. सो उसके लिए आपकी जो ये वाली मैट्रिक्स है, ओके, जो आपने अभी जनरेट की, वो उसका बेस हो जाएगी. जैसे A हुआ तो A1 A2 का बेस होगा. ठीक है. A2 A3 का बेस होगा. ये एग्जांपल है जो कि मैंने आपको एक्सप्लेन किया. अगर रियल टाइम एग्जांपल में जाइए, ठीक है, तो सपोज लेट्स से आई वांट टू गो, ओके, दिल्ली ले लो. ठीक है. मुझे गुजरात से दिल्ली जाना है. ठीक है. तो मैं वाया राजस्थान जाऊं तो मुझे सही रहेगा, या फिर वाया MP जाऊं तो सही रहेगा. तो अभी मेरे पास क्या है कि गुजरात से MP, MP से यूपी और यूपी से दिल्ली. ठीक है. ये मेरे पास अभी रूट है. सो दैट इज 30. But do I have any another shortest route via some another place? So we know that yes, there is a shortest route, Gujarat से राजस्थान, राजस्थान से दिल्ली. ठीक है. So in the next vertex, when we are checking, why we are checking this discussion is happening because the reason is like कि हम सारे वर्टेक्स को क्यों हम लोग चेक करें, जबकि हमारे पास मैट्रिक्स तो आ गई है. सिर्फ एक ये इन्फिनिटी का हम लोग चेक कर लेते हैं तो बाकी का हो गया. ऐसे नहीं होता है. हमें सारे वर्टेक्स वाया वर्टेक्स चेक करने. ठीक है. और हमें एक मैट्रिक्स बी जनरेट करनी है. वो बी मैट्रिक्स जो है ना, वो क्या आइडेंटिफाई करती है? द शॉर्टेस्ट अवेलेबल पाथ. ओके. और उस बी मैट्रिक्स से हम अपनी पाथ मैट्रिक्स बनाते हैं. दैट बाय एनी केस अगर उस बी मैट्रिक्स में 0 वैल्यू है तो पाथ मैट्रिक्स 0 हो जाएगा. एंड बाय एनी केस अगर उस बी मैट्रिक्स में नॉन जीरो वैल्यूज है तो पाथ मैट्रिक्स 1 हो जाएगी, ठीक है। और ये सारा आपको कैलकुलेट नहीं करना है, ये सारी चीजें आपका कंप्यूटर करता है, ठीक है। बट हाउ दैट इज कैलकुलेटिंग, दिस इज द एग्जाम्पल, वो कौन से लॉजिक पे काम करता है, तो दिस इज द एग्जाम्पल। ओके, सो नाउ वी आर डन विथ योर वाया वर्टेक्स 1। अभी हमें वर्टेक्स 2 के लिए करना है, ठीक है। तो 2 के लिए ये ए ऑफ 1 जो है वो आपका रेफरेंस मैट्रिक्स हो गया, क्योंकि देखो पाथ मैट्रिक्स में क्या कर रहे थे, ए ऑफ 1 निकालने के लिए ए ऑफ 0 क्रॉस, ठीक है। ए ऑफ 2 के लिए क्या कर रहे थे, ए ऑफ 1 क्रॉस ए ऑफ 1, ठीक है। तो अभी वाया वर्टेक्स 2, दिस ए ऑफ 1 विल बी योर रेफरेंस मैट्रिक्स, इसके साथ कंपेयर करना है, इसके डिस्टेंसेस के साथ। ओके, अभी हम वाया वर्टेक्स 2 कर रहे हैं, तो ये जो 2 की वैल्यूज है रो और कॉलम की वो एज इट इज जाएगी, बाकी की जिन कॉलम्स है वो आपको फिल करनी है। तो हमें तो पता है कि डायगोनल्स कोई लूप तो है नहीं, तो डायगोनल भी ऐसे ही जाएगा। मीनिंग मैट्रिक आई मीन स्पेसेस क्या हो गई, 1 2 3 1 2 4, ओके, 3 2 1 एंड 3 2 4, 4 2 1 एंड 4 2 3। तो इतनी वर्टेक्सेस के लिए हमें वाया वर्टेक्स 2 डिस्टेंस फाइंड आउट करना है, ठीक है। तो ये हमने प्रिपेयर करना शुरू कर दिया, प्रिपेयरिंग मैट्रिक्स वेयर पाथ आर वाया वर्टेक्स 2। सो अभी इस मैट्रिक्स का नाम है ए ऑफ 2, ठीक है। ए ऑफ 2 के लिए देखो, ए ऑफ 2 के लिए उसकी रोज और उसकी कॉलम्स हमने ऐसे ही प्रिंट कर दी जो कि ए ऑफ 1 में मिली थी, ठीक है। और डायगोनल, व्हाट वी आर डूइंग विद द डायगोनल, नो लूप्स, सो डायगोनल्स आर 0 0 एंड 0। Fine. Now start with the missing values. A of 3. I want to reach 3 from 1 via 2. So A of 3 के साथ compare करो. So see, here it is written A of 1, 1 3. Okay. And बीच में हम लोग 2 insert कर रहे हैं vertex via 2. Okay. So A of 1 1 2, A of 1 1 3. Do I get any updated values? No. It is infinity only. So हमने यहाँ पे कुछ update नहीं करना है। A 1 of 3 में वो ऐसे ही जाएगा, ठीक है। 1 of 4 अगर हम करते हैं तो 1 of 4 A of 1 में क्या था, 12। अभी 2 को बीच में इंसर्ट करो, सो 1 to 2 एंड 2 to 4। ओके, सो A of 1 1 to 2, A of 1 2 to 4, सो 13 plus 30, सो दैट इज ऑल्सो 43। तो 12 को भी हमें अपडेट करने की कोई जरूरत नहीं, ठीक है। तो वो दोनों वैल्यूज यहाँ पे ऐसे की ऐसे, दैट मीन्स बोथ द डिस्टेंसेस आर द शॉर्टेस्ट पॉसिबल राइट नाउ करंटली, ठीक है। अभी हम लोग चलते हैं 3 to 1 वाली, ओके। 3 to 1 पे चेक करो, तो वो क्या है, 15 है ए ऑफ 1 में। इससे कम डिस्टेंस हमें मिल रहा है वाया वर्टेक्स 2, नो। क्या हो रहा है, 15 इज ऑलरेडी लेस देन 46, तो 15 को भी हम अपडेट नहीं करेंगे, 15 भी यहाँ पे एज इट इज आएगा, ठीक है। अभी उसके बाद 3 4, 3 4 की डिस्टेंस क्या है, 11। ओके, अगर हम वर्टेक्स 2 यहाँ पे बीच में इंसर्ट करते हैं तो क्या हमें एक डिस्टेंस मतलब ऑप्टिमाइज डिस्टेंस मिल रहा है उससे छोटा, नहीं। 11 इज ऑलरेडी द शॉर्टेस्ट वन, तो वो भी हम अपडेट नहीं करेंगे। अभी 4 पे आओ, 4 1 की एग्जिस्टिंग वैल्यू क्या है डिस्टेंस की, 17। ओके, तो हम चेक करेंगे 17 से कम मिल रहा है डिस्टेंस, अगेन वी आर नॉट गेटिंग दैट डिस्टेंस, तो यहाँ पे भी 17 एज इट इज रहेगा। 4 3 जो कि इंफिनिटी था, ठीक है। तो 4 गया वर्टेक्स 2, हमें शॉर्टर पाथ मिल रहा है, यस। इंफिनिटी इज नॉट लेस देन 42, ओके। तो हम यहाँ पे 4 3 की वैल्यू अपडेट करेंगे, 42 लिख देंगे। तो आखिर में आपका A of 2 would look something like this, okay, that from 4 via 2, the shortest distance to reach 1 is 17. From 4 via 2, the shortest distance to reach 2 is 30. From 4 via 2, the shortest distance to reach 3 is 42. Okay, or 4 of 4 तो 0, ठीक है। You guys got this? Did you guys get it or not?
Yeah. Yes.
So this is a bit lengthy algorithm. Okay, that's why I need at least some confirmation at each and every step. ओके ये मैं ये देखने के लिए नहीं बोल रही हूँ कि आप लोग मतलब सुन रहे हो कि नहीं सुन रहे हो. ऑब्वियसली अगर सुन रहे हो तो समझ में भी आ ही रहा होगा, बिकॉज दिस इज द सिंपलेस्ट रिप्रेजेंटेशन फॉर द एक्सप्लेनेशन. कि ये क्योंकि ये थोड़ा मैथमेटिक्स है तो भी थोड़ा इजी है. तो आई होप एवरीवन इज क्लियर हाउ वी आर जनरेटिंग a of 2. ठीक है. In the similar manner, in this similar manner, we are preparing matrix now via vertex 3. ठीक है. सेम थिंग कर रहे, कुछ कुछ चेंज नहीं है, बस अभी बीच में जो वर्टेक्स है वो क्या है 3 है. ठीक है. और उसकी देखो मैट्रिक्स जनरेट कर रहे हैं a of 3 की. ऑलराइट, a of 3 की मैट्रिक्स हम लोग जनरेट करवा रहे हैं. जस्ट अ मिनट. या अभी एक चेंज देखो, मैंने जो कहा था एक यहाँ पे एक चेंज है. यहाँ पे अगर a of 2 में वाया वर्टेक्स 2 to 4 उसकी वैल्यू क्या है 30. ओके. यहाँ पे हम लोग ये देख रहे थे कि 2 to 4, 2 से 4 मुझे पहुंचना है वाया वर्टेक्स 2, तो वैल्यू क्या है 30. ओके. और अगर ऐसे समझो तो कि मतलब मुझे लेट्स से x जगह से y जगह जाना है. ठीक है. x जगह से y जगह जाना है. फिलहाल 30 किलोमीटर चल रहे. ठीक है. बट अगर मैं उसी दो जगह पे x से y ओके वाया कोई एक z वैल्यू से जाऊं. ठीक है. तो मेरा डिस्टेंस क्या है 23. तो देखो ये अपडेट हो गया. और सिंप्लीफाई मैनर अगेन, गुजरात से मैं दिल्ली जा रही हूँ. ओके. गुजरात से मैं दिल्ली जा रही हूँ तो गुजरात एमपी यूपी और दिल्ली ऐसे जा रही हूँ तो 30 किलोमीटर हाइपोथेटिकली. ठीक है. लेकिन अगर मैं वाया राजस्थान जाती हूँ तो गुजरात राजस्थान 100 किलोमीटर कितने हुए 23. तो मैंने ऑब्वियस है कि मैं शॉर्टेस्ट पाथ ही जाके चूज करूंगी. मैं तो वाया पाथ तो चूज नहीं करूंगी. मुझे अभी रोड ट्रिप नहीं करनी है, मुझे जल्दी पहुंचना है दिल्ली. ठीक है. तो आई एम गोइंग टू चूज और से आई एम गोइंग टू अपडेट माई वैल्यू टू 23. आर यू गाइस गेटिंग नाउ व्हाट इज हियर? जहां कहीं पे भी आपको डिस्टेंस वैल्यू कम मिल रही है देन द प्रीवियस मैट्रिक्स, तो वो उस जगह पे आप अपडेट कर रहे हो. स्टेप्स सारे सेम है, बस सिर्फ वर्टेक्स जो है ना वाया वर्टेक्स वो चेंज कर रहे हो हर बार, हर एक साइकिल के बाद. ठीक है. नाउ इफ यू डू टिल वर्टेक्स 4 ओके एट द एंड a of 4 जो मिलेगा वहां पे आपको फाइनाइट वैल्यूज मिलेगी. इनफाइनाइट वैल्यूज. देखो इनिशियली सबसे पहले जब हमने एडजेसेंसी मैट्रिक्स बनाई थी इस पर्टिकुलर ग्राफ की, तो हमें कहीं पे इनफाइनाइट वैल्यूज मिल रही थी, मतलब हमें कुछ डिस्टेंस पता नहीं. ओके. बट आफ्टर आफ्टर डूइंग दिस कैलकुलेशन ऑफ Warshall, ओके ये a of 4 है जो कि आपकी बी मैट्रिक्स रिप्रेजेंट करता है. ठीक है. आप अगर देखो तो हमारी यहाँ पे वैल्यूज है वो फाइनाइट वैल्यूज है. ठीक है. या तो 0 है या तो फाइनाइट, लाइक इट कैन बी डिटरमाइंड, कोई इनफाइनाइट वैल्यू नहीं है. so that means what you got this b. now if you want to you know go and matrix p for this. ओके. अगर मैं पाथ मैट्रिक्स मेरा बनाऊं तो पाथ मैट्रिक्स क्या बोलता है कि सिंपल पाथ है या नहीं है. ठीक है. तो जितनी भी नॉन जीरो वैल्यूज है वो सारी 1 जितनी भी जीरो वैल्यूज है वो सारी जीरो। तो डायगोनल मेरा जीरो हो गया, 1 2 3 और 4, ठीक है। मेरा डायगोनल जीरो हो गया, बाकी की सारी नॉन जीरो वैल्यूज है, ठीक है। तो दिस इज 1 1 एंड 1, ओके। अगेन दिस इज 1 1 एंड 1, ओके। 1 1 एंड 1, एंड हियर टू 1 1 एंड 1। तो ये मेरा इस करस्पॉन्डिंग मैट्रिक्स बी का पाथ मैट्रिक्स हो गया, ठीक है। तो नेट किया इतना, वो जो भी आप पहले A0 क्रॉस A0, फिर A1 क्रॉस A1, A2 क्रॉस A2, A3 क्रॉस A3, फिर जाके सारे मैट्रिक्स ऐड करना, उसको थोड़ा सिंप्लीफाई किया ऐसे कि जहां जहां आपको डिस्टेंस कम मिल रहा है, wherever you are getting the distance, you know, less distance, there you are going and updating, okay. So now how can we derive the formula? What is the working formula here? अगर हम इसका जनरलाइजेशन निकालने जाए, okay, तो इसकी वर्किंग फॉर्मूला क्या हुई? The working formula of your Warshall's algorithm looks something like this: that in your given matrix, okay, A of k at position ij, ठीक है, k क्या है? आपकी इंटरमीडिएट वर्टेक्स, दैट मीन्स वर्टेक्स, जिस वर्टेक्स से y आप ढूंढ रहे हो सारे डिस्टेंसेस, ओके। सो फॉर दैट A of k at position ij, which value you are going to place the minimum out of A of k minus 1 ij or A of k minus 1 I k plus k minus 1 kj। अदर वर्ड्स, अगर मुझे फाइंड आउट करना है कि लेट्स से मेरा k इंटरमीडिएट वैल्यू जो है, माय k वैल्यू इज 1, ओके, मेरा इंटरमीडिएट वर्टेक्स है 1, वाया 1 मुझे 0 to 2 देखना है, तो मेरी i वैल्यू हो गई 0, ओके, मेरी j वैल्यू हो गई 2। तो मैं क्या सर्च कर रही थी? a ऑफ, यहाँ पे a ऑफ, यहाँ पे मैं प्लेस क्या कर रही थी? a ऑफ 1 में एट 0 2, a ऑफ 0 या तो मिनिमम वैल्यू आउट ऑफ एनी टू, a ऑफ 0 0 2, ओके, जो भी मिनिमम है, या तो फिर क्या कर रही थी मैं? a ऑफ 0 to 1, ओके, क्योंकि 1 मेरा इंटरमीडिएट वर्टेक्स है या तो वाया वर्टेक्स है, प्लस a ऑफ 0 1 to 2, जो भी इन दोनों में, इन दो जो भी मिनिमम वैल्यू है वो मैं अपने a ऑफ 1 की मैट्रिक्स में प्लेस कर रही थी। फॉर एग्जाम्पल यहाँ पे 20 15 और 28, ओके ओके, यहाँ पे आप देखो 23 है, ठीक है, ओके, इट इज 2 4, यहाँ पे 2 4, तो मेरा a ऑफ k क्या है? अभी k है मेरा 2, तो a ऑफ k सो 2, ओके। सो यहाँ सॉरी, a ऑफ k क्या है मेरा? ठीक है, सो 2 to 4 वैल्यू मेरी 30 है, ठीक है, और वाया 3 समेशन वैल्यू क्या है मेरी? 23। सो दोनों की, दोनों में से जो भी मिनिमम है, या तो 30 या तो वो आपको यहाँ पे प्लेस करनी है, ठीक है। तो 30 में से 30 और 23 में से 23 सबसे छोटा था, तो मैंने 23 को अपडेट किया। तो दिस इज द वर्किंग फॉर्मूला, ओके, दैट इन योर एग्जिस्टिंग मैट्रिक्स, ओके, सो दैट वाज a ऑफ 4। आप कौन सी मिनिमम वैल्यू डालोगे? यू आर गोइंग टू कंपेयर आउट ऑफ दीज टू, दोनों में से जो भी मिनिमम वैल्यू है वो आप प्लेस कर दोगे। एवरीबडी गेटिंग इट और नॉट?
Yes, ma'am.
डाउट है किसी को? बिकॉज विद दिस चैप्टर इज ओवर। ओके, मैं इस चैप्टर को भी मतलब ये ग्राफ ट्रीज ऑलरेडी अपलोडेड है, ग्राफ्स आई विल अपलोड. ओके, किसी को कोई भी डाउट ग्राफ्स में? ओके, तो अभी फिल yes, we are completed with your unit number 3 and it is 1:35. Okay, okay. We can have a look at selection and insertion, the logics. Okay, इतना खत्म हाँ हो जाएगा. चलो. Okay. Fine. See, we are starting with your new topic, that is of insertion sort. Okay. Insertion sort. Listen to me first. Okay. Just okay. See, your insertion sort works on the principle of dividing your array into sorted list and unsorted list. Okay. What it is going to do, it is going to, at the very beginning only, it will divide your array. How we are going to divide your array? You are going to, take the first element in your array as a part of sorted list. एक एलिमेंट है, किसी के साथ कंपेयर नहीं करना है, तो ऑब्वियसली वो अपनी सॉर्टेड जगह पे ही है. ठीक है, तो what you are going to do, you are going to keep that index 0 as a part of sorted list. ठीक है, बाकी का जो इंडेक्स वैल्यू है, लाइक फ्रॉम 1 to n-1, वो सारा पार्ट हो गया आपका अनसॉर्टेड सब लिस्ट का. ठीक है, इंसर्शन सॉर्ट. अभी कैसे काम करता है? कोई एक वैल्यू आपको उठानी है अनसॉर्टेड सब लिस्ट से. ठीक है, लेट्स से यू आर टेकिंग वन वेरिएबल फ्रॉम दैट अनसॉर्टेड लिस्ट एंड यू हैव टू प्लेस इन द you have to find an appropriate place in the sorted list. Okay, and place there.
Ma'am, your
Suppose
screen is showing
our
still
first
syllabus.
variable, what?
Your screen is showing still syllabus portion.
हाँ, वो मैंने रखा है ताकि आप लोग मुझे सुनो, सीधा एग्जाम्पल पे ध्यान ना दो इसलिए. ठीक है, क्योंकि वहां पे सॉल्व एग्जाम्पल है आपके सामने. वहां पे मैं अभी थियोरी बोल रही हूँ, तो थोड़ी थियोरी सुन लो पहले. ठीक है, कैसे काम करता है? सबसे पहला स्टेप है आपको, लाइक जो भी आपका सपोज 0th इंडेक्स है उसको आप सॉर्टेड लिस्ट कंसीडर कर रहे हो. ठीक है, तो 1 से लेके n-1 की जो सब एरे है वो आपका अनसॉर्टेड सब लिस्ट हो गया. ठीक है, उसके बाद आप क्या करोगे, अनसॉर्टेड सब लिस्ट में से पहली वैल्यू उठा रहे हो, ठीक है, ये तो कोई भी वैल्यू लास्ट से उठाओगे या तो फर्स्ट से, उस हिसाब से पूरा लॉजिक तैयार होगा। लेकिन सपोज अनसॉर्टेड से पहली आप वैल्यू उठा रहे हो, सो यू आर पिकिंग वन वैल्यू फ्रॉम द अनसॉर्टेड लिस्ट एंड यू आर गोइंग टू फाइंड व्हाट द अप्रोप्रिएट प्लेस ऑफ दैट वैल्यू इन योर सॉर्टेड सब लिस्ट। ठीक है, देखो सपोज फॉर एग्जांपल यहाँ पे मेरे पास 0 से लेके 5 तक की साइज है, ठीक है, इसको हटाओ, my n is equals to 6. I would like you guys to note this example down, okay, somewhere. My n is equals to 6, okay, और ये मेरे कुछ randomly inserted मेरे numbers है array में. So my array size is 6 and index value 0 to 5, and these are some randomly inserted numbers in my array A. ठीक है, अभी मैंने आपको बोला कि एक सब लिस्ट को आपको सॉर्टेड रखना है, दूसरी को आपको अनसॉर्टेड रखना है। लेट्स से आई चूज इंडेक्स एज द पार्ट ऑफ माय सॉर्टेड सब लिस्ट, ओके, दैट मींस आई हैव टू डू समथिंग विद दिस सो दैट इट एट द एंड में मुझे कुछ ऐसा रिजल्ट मिले। ठीक है, मुझे सॉर्टिंग इस हिसाब से करनी है कि एंड में मुझे जो हाईलाइटेड आपको दिख रहा है वैसा रिजल्ट मिले। ठीक है, तो नाउ लेट्स सी हाउ इट इज एक्चुअली वर्किंग। लेट्स से आपने डिवाइड कर दिया, ठीक है, और मैंने कहा कि आप कोई, तो सपोज मैंने 4 को पिक किया, ओके, 4 आई वांट टू फाइंड एन अप्रोप्रिएट प्लेस ऑफ दिस 4 इन माय सॉर्टेड लिस्ट। ठीक है, I want to find an appropriate place for this value 4 in my sorted list. तो मैं क्या करूंगी, सबसे पहले इस 4 को मैं एक टेम्पररी वेरिएबल में स्टोर कर रही हूँ। That means I'm making a copy. I'm making a copy of this value. So यहाँ पे मैंने टेम्पररी वेरिएबल में मैंने उसको स्टोर करवा दिया सबसे पहले। ठीक है, अब मैं क्या करूंगी, अगर मेरी सॉर्टेड वैल्यू, नाउ आई एम गोइंग टू चेक if my sorted value if my sorted value is greater than my temp value। temp में मैंने क्या कॉपी किया है, मेरा जो भी मेरा वेरिएबल है जो मैंने अनसॉर्टेड से उठाया था उसको। ठीक है, अगर मेरी सॉर्टेड वैल्यू, जो सॉर्टेड वैल्यू है वो मेरे टेम्प वेरिएबल से बड़ी है, इफ दैट इज द कंडीशन, तो मैं क्या करूंगी, मेरी जो सॉर्टेड वैल्यू है उसको एक प्लेस राइट शिफ्ट करूंगी। ठीक है, अभी राइट में मैं अगर इस एग्जांपल में देखने जाओ, if I'm shifting this 5 to right, okay, then there is 4. So some of you will think that madam, then we are going to lose this 4. What about this 4? Then the answer for this is we have already stored value 4 in temp. So basically we can overwrite this value. Okay, so there won't be any problem in shifting 5 to one step left, right. Why? Because the sorted value, that is 5, is greater than the value 4. So in that case, shift your sorted value to right side one step. तो अगर मैं इसको shift करती हूँ, तो now the empty space is index 0. Okay, and here I have 5. तो 5 अभी sorted का part है, तो देखो index 1 मैंने green कर दिया। ठीक है, अभी यहाँ पे हमने place नहीं किया 4. Again we are going to see that do we have any value in the sorted list? Okay, so यहाँ पे मेरी कोई वैल्यू है नहीं। Okay, my j is, I mean like I am at index 0 and which is empty, तो यहाँ पे 4 डाल दूंगी। ठीक है, तो अभी देखो 4 और मेरा sorted list are part of my sorted list. Okay, 10 1 6 2 are the part of my unsorted list. ये स्टेप समझ आया? ये स्टेप समझ आया कि 4 को कैसे उसकी सही जगह मिली सॉर्टेड लिस्ट में?
Got it.
Okay, now you are going to do the same procedure for this temp. ठीक है। टेम्प को हमने पहले कॉपी किया टेम्पररी वेरिएबल में, ठीक है। तो बेसिकली वी कैन नाउ ओवरराइट दिस टेम्प। अगर मैं इसको हटा भी दूं तो भी कोई फर्क नहीं है अभी, क्योंकि मेरा वेरिएबल वैल्यू 10 है वो टेम्प में है, ठीक है। अभी इसको चेक करो, सॉर्टेड वैल्यू ग्रेटर देन माय टेम्प। सॉर्टेड वैल्यू क्या है अभी 5, 5 इज ग्रेटर देन 10, नो, ओके। और यहाँ पे देखो 4, 4 is greater than my 10, no, okay. So now what I'm going to do, if this case occurs, okay, कि जहाँ पे आपकी सारी sorted रेडी कम है, तो क्या करोगे, यहाँ पे आप 10 as it is रखोगे। Why doing that? Because all the values in the sorted list are already my temp variable, तो 10 already उसकी सही जगह पे है, ठीक है। नेक्स्ट टेम्पररी जो है तो मेरा नंबर वो है 1, जो कि मैं नेक्स्ट सॉर्टेड लिस्ट में मेरा नंबर है वो है 1। तो अगेन आई एम गोइंग टू टेक 1 इन टेम्प, ओके। सो दिस स्पेस इज नाउ अवेलेबल फॉर ओवरराइट। अभी गो एंड चेक, 10 is greater than 1, yes। So what you are going to do, you are going to move the 10 to one step right, ठीक है। ये यहाँ पे एम्प्टी हो गया, ये जगह एम्प्टी हो गई अभी, ठीक है। अभी अगेन चेक, 5 इज ग्रेटर देन 1, यस 5 इज ग्रेटर देन 1। तो क्या करोगे, इसको 5 को वन स्टेप राइट में पुश किया, ठीक है। तो 5 इज हियर। अभी अगेन 4 इज ग्रेटर देन 1, 4 इज ग्रेटर देन 1, तो क्या करोगे, 4 को एक स्टेप राइट पुश किया, नो। देन व्हाट कैन आई डू, हियर, तो वहां पे आ गया। तो अभी मेरी सॉर्टेड ऑर्डर क्या हुई, 1 4 अनसॉर्टेड 6 और 2। अब नेक्स्ट टेम्प की वैल्यू हमने ली 6, ओके। अब कैन ओवरराइट इन प्लेस ऑफ 6, कंपेयर इट विद 10, देन 6, सो व्हाट आई नीड टू डू, 10 दैट, ठीक है, ये जगह खाली। नाउ अगेन 10 sorry 6 greater than 5, no। Then what you are going to do, you are going to place your here only, okay, you are going to place here, there is no shifting, so यहाँ पे आपका आ गया 6, ठीक है। Now this is the part of sorted list, the only one which is remaining in the unsorted is 2। आपका next temp variable I mean temp value क्या हो गई 2। अभी 2 से कंपेयर करो, 10 greater than, yes, तो 10 को एक से राइट में शिफ्ट करो, ठीक है। ये शिफ्ट, ये जगह खाली हो गई। 6 ग्रेटर देन 2, यस, क्या करो, शिफ्ट कर दो, ठीक है, ये वाला खाली हो गया। 5 ग्रेटर देन 2, यस, क्या करना है, 5 को शिफ्ट करो राइट, एक स्टेप ही राइट करना है, ठीक है। अगेन 4 ग्रेटर देन 2, यस, तो वापस से शिफ्ट कर दो यहाँ पे, ठीक है। 1 ग्रेटर देन 2, नो। तो क्या क्या हुई, फॉल्स हुई, योर सॉर्टेड वैल्यू इज वैल्यू इज इट इज द करेक्ट पोजीशन। तो आपका ये सॉर्टेड एरे हो गया। को हम इंसर्शन सॉर्ट क्यों बोलते हैं, आफ्टर ऑल दीज थिंग्स इंसर्शन सॉर्ट क्यों बोलते हैं, क्योंकि हर एक इशन और से हर एक मूव के बाद हम क्या कर रहे हैं कि हम अनसॉर्टेड की किसी एक वैल्यू को सिलेक्ट करके सॉर्टेड में इंसर्ट करवा रहे हैं। वी आर picking up one value from the unsorted list and we are inserting it into the sorted list, okay, and the name is insertion sort, okay, that's why the name is insertion sort। तो अगर हम लॉजिक लिखना चाहे, if we go and write the logic for the same, ओके, तो क्या होगा, ये पूरी मतलब एक पूरे ये तो एरे ही है हमारा, ठीक है। तो एरे के लिए हम लोग यहाँ पे एक फॉर लूप लेंगे। सो लाइक फॉर, क्योंकि ये एरे हमें चलानी है, ठीक है। और एरे किसका होगा, अनसॉर्टेड का। एरे किसका होगा, अनसॉर्टेड का। तो हम लोग कहाँ से शुरू कर रहे हैं, 1 से।
1.
ओके, फॉर I is equals to 1. Okay, I should be less than my array size. Okay, or say yeah, array size. Okay, and I plus plus. तो उसके अंदर, फॉर के अंदर हम लोग क्या करवा रहे थे, सबसे पहले तो हम लोग ले रहे थे हमारी जो a ऑफ i की जो हम पिक कर रहे हैं वैल्यू, उसको टेम्प में स्टोर करवाया। तो टेम्प इज इक्वल्स टू a ऑफ i, ठीक है। उसके बाद हमने एक वेरिएबल लिया जो कि है j। j क्या है, j इज I minus 1. So what is this j? J is the, you can say, index part for your sorted list. Okay, तो अगर हम इसको 1 को अगर हम I ले रहे हैं तो मेरा j क्या होगा, I minus 1। तो यहाँ पे मेरा j हो गया, ठीक है, जो कि सॉर्टेड की इंडेक्स को पॉइंट करेगा, I अनसॉर्टेड की इंडेक्स को पॉइंट करेगा, ठीक है। अभी नेक्स्ट हम क्या कर रहे हैं, एक कंपैरिजन हो रही है, दो दो इसकी और इसकी, सॉर्टेड की वैल्यू और अनसॉर्टेड की कंपैरिजन हो रही है। लेकिन कहाँ तक, जब तक कि हमारा जो जे है वो ग्रेटर देन और इक्वल टू 0 रहे तब तक। ओके, वंस यहाँ पे अगर जे मेरा 0 को पॉइंट कर रहा है, ठीक है, तो मुझे मतलब स्टॉप कर देनी है। उसके बाद अगर जे जे लेस देन 0 हो गया तो मुझे नहीं जाना है आगे, ठीक है। तो यहाँ पे एक कंडीशन रहेगी कि while j is greater than or equal to my 0, okay, okay, while my j is greater than or equal to 0, okay, and हम लोग देखा है कि जो j की वैल्यू है वो टेम्पररी से बड़ी है या नहीं। Okay, so a of j, that means the sorted value is greater than my temp। अगर ये दोनों चीजें सही है, if these both are true, then in that case आप a of j plus 1 की वैल्यू अपडेट करोगे। ओके, a of j plus 1, that means the right side of j, हम लोग एक हट रहे हैं ना, राइट साइड जा रहे हैं j के। So a of j plus 1 will get the value of a of j, okay, and you will decrement your j। देखो जैसे I, ये समझो, जैसे ही I यहाँ पे इंक्रीमेंट हो रहा है, पहले हमने 4 लिया, फिर 10 लिया, फिर 1 लिया, ठीक है। तो उसी हिसाब से जब भी हम कंपैरिजन कर रहे हैं तो हम कैसे जा रहे थे, फ्रॉम राइट टू लेफ्ट, ठीक है। पहले 5, फिर 4, फिर 2, लाइक दैट, ठीक है। तो जैसे जैसे I की वैल्यू बढ़ रही है, दैट मीन्स इन द फॉर लूप व्हेन वी आर डूइंग I प्लस प्लस, inside my while loop there will be decrementing j, so that will be j minus minus। ओके, और अगर बाय एनी चांस ये while की लूप, ओके, नहीं चल रही मतलब j इज ग्रेटर देन और इक्वल टू 0, ठीक है, बट a of j is not greater than 10, तो क्या होगा कि जहां भी आपका a of j plus 1 है, ठीक है, जहां कहीं भी a of j plus 1 मतलब जो भी आपकी empty वैल्यू है, वहीं पे आपको आपका temp स्टोर करवाना है। दैट मीन्स इट वॉज द अप्रोप्रिएट प्लेस, ठीक है, समझ आया। स्टूडेंट एनी क्वेरी हियर।
No.
यहाँ पे आपका लॉजिक ये खत्म होता है। तो कोई क्वेरी है यहाँ पे, ओके, देखो ये आपको है ना इम्प्लीमेंट नहीं करना है, ठीक है, ये प्रैक्टिकल सेशन में भी नहीं है, इम्प्लीमेंट नहीं करना है, लेकिन ये काम कैसे करता है ना वो तो पता होना चाहिए, इंसर्शन, और ये उसका लॉजिक है, ये जो फॉर लूप दिख रही है वो उसका लॉजिक है, ठीक है। सो वी हैव कंप्लीटेड योर इंसर्शन आल्सो, ओके, सिलेक्शन और मर्ज बाकी है। मोस्ट प्रोबेबली मैं इन सब की नोट्स अपलोड कर दूंगी, ठीक है, ई कंटेंट में। एक आज हमने ग्राफ कंप्लीट किया, सो आई एम गोइंग टू अपलोड दैट ग्राफ नोट्स, आई मीन दैट पीपीटी, okay, and notes of these sortings, fine, or if ppt is ready by then, okay, then I'll upload the ppt itself, otherwise notes of these या तो फिर ये excel, okay, I will upload it for your reference, right? Fine, we are going to wrap up till here, keeping it till here your session. Thank you all for attending the session. PD students, if any, numbers in the chat. Please don't leave the session yet. Okay. D2D students AI. Okay. AI 1 to 10. 11 to 20. 20 to 30. 31 to 40. 41 to 50. 50 to 60. 60 to 75. Okay. I hope everybody has filled up their attendance. Don't leave the session